According to the National Electrical Code, NEC, Section 800.100, fire protective cables, designated as FP, are generally required for cable installations inside buildings. However, Section 800.41 subsection B provides exceptions for short lengths of cable. This exception states that cables and conductors passing through fire-rated walls, partitions, floors, or ceilings shall be listed as having adequate fire-resistant characteristics. There is an exception to this. In raceways or plenum-rated, limited-use cables, or direct buried cable, short sections of cables or conductors that are suitably protected and not in concealed spaces except as permitted in 800.41 subsection C, shall be permitted. When applying this to a situation where the length of the cable inside the building is under 20 feet, and it will be suitably protected in a raceway, it is permissible to install the LMR-400-DB cable without transitioning to an LMR-400-FR cable. It's important to note several additional considerations. Firstly, the LMR-400-DB cable should be properly secured and supported to prevent damage. Secondly, the cable should not be run through areas with excessive heat or moisture. Thirdly, the cable should not be subjected to physical damage, such as pinching or crimping. To elaborate on NEC Section 800, it primarily covers communications circuits. This includes telephone, radio, television, and other communication systems. Article 800 addresses wiring methods and materials for communication circuits that are not an integral part of a fire alarm system, signaling system, or power-limited circuit. Within NEC 800, several key sections are relevant to internal building cable runs. Section 800.2 defines terms that are specific to communication circuits, such as abandoned cable, communications equipment, and point of entrance. Section 800.25 addresses the protection of communications equipment. This section requires that communications equipment be grounded and protected from overvoltage. Section 800.44 details the requirements for cable markings. This section specifies that communications cables must be marked with their voltage rating, fire rating, and other relevant information. Section 800.50 covers the general wiring methods for communication circuits. This section outlines the acceptable methods for installing communications cables, including the use of raceways, cable trays, and other support systems. Section 800.52 addresses the installation of communications cables in hazardous locations. This section specifies the requirements for cables installed in areas where flammable gases, vapors, or dust may be present. Section 800.93 details the grounding methods for communications circuits. This section specifies the requirements for grounding communications equipment and cables to ensure safety and prevent electrical shock. Focusing on the fire rating requirements for communications cables, the NEC specifies different levels of fire resistance based on the cable's intended use and location. Cables intended for general use in buildings must have a fire rating of CL2 or CL3. Cables installed in risers, which are vertical shafts that run between floors, must have a fire rating of CL2R or CL3R. Cables installed in plenums, which are air handling spaces above suspended ceilings or below raised floors, must have a fire rating of CL2P or CL3P. The fire rating of a cable indicates its ability to resist the spread of fire. Cables with higher fire ratings are more resistant to fire and are less likely to contribute to the spread of a fire. The NEC also specifies requirements for the installation of communications cables in specific locations. Cables installed in conduits must be installed in accordance with the requirements of Chapter 3 of the NEC. Cables installed in cable trays must be installed in accordance with the requirements of Article 392 of the NEC. Cables installed in suspended ceilings must be supported in accordance with the requirements of Section 300.11 of the NEC. When considering the practical implications of these requirements, the primary goal is to ensure the safety of building occupants and to prevent the spread of fire. By using cables with appropriate fire ratings and installing them properly, the risk of fire damage and injury can be significantly reduced. When dealing with short cable runs, the NEC provides some flexibility, but it's essential to understand the specific requirements and exceptions that apply. If a cable run is less than 20 feet and is installed in a raceway, it may be possible to use a cable with a lower fire rating. However, it is always best to consult with a qualified electrical inspector to ensure that the installation meets all applicable requirements. In addition to the NEC requirements, local building codes may also have specific requirements for the installation of communications cables. It is important to check with the local building department to ensure that the installation complies with all applicable codes. In summary, NEC 800 provides a comprehensive set of requirements for the installation of communication circuits. By following these requirements, you can ensure the safety and reliability of your communication systems and prevent the spread of fire. In situations where a cable is run from a rooftop into a building, understanding the transition and the applicable codes is essential. Firstly, the point where the cable enters the building is considered a potential entry point for moisture and pests. Proper sealing around the cable entry is crucial to prevent water damage and pest infestation. Secondly, grounding the cable at the entry point is important for electrical safety and to protect equipment from lightning strikes. The grounding should comply with NEC requirements for communication systems. Thirdly, the type of cable used for the outdoor portion of the run may differ from the type used indoors, depending on the environmental conditions. Outdoor cables are typically designed to withstand sunlight, moisture, and temperature extremes. Fourthly, transitioning from an outdoor rated cable to an indoor rated cable should be done in a junction box or other suitable enclosure. This enclosure provides a protected space for making the connection and helps to prevent moisture from entering the building. Fifthly, labeling the cables is important for future maintenance and troubleshooting. Cables should be clearly labeled at both ends to indicate their function and destination. Sixthly, when running cables through walls or floors, fire-stopping material should be used to maintain the fire resistance of the building. Fire-stopping materials are designed to prevent the spread of fire and smoke through openings in walls and floors. Seventhly, supporting the cables properly is important to prevent damage and ensure their longevity. Cables should be supported at regular intervals using cable ties, clamps, or other appropriate hardware. Eighthly, avoiding sharp bends in the cable is important to maintain signal quality. Sharp bends can cause signal loss and interference. Ninthly, ensuring that the cable is not subjected to excessive tension is essential to prevent damage. Tension can cause the cable to stretch and weaken, leading to failure. Tenthly, documenting the cable installation is important for future reference. The documentation should include a diagram of the cable run, the types of cables used, and the locations of all connections and terminations. Finally, consulting with a qualified electrician or communications technician is always a good idea, especially if you are not familiar with the applicable codes and standards. A professional can ensure that the installation is done safely and correctly. In addition to these practical considerations, it is also important to be aware of the potential hazards associated with working with communications cables. These hazards include electrical shock, falls, and exposure to hazardous materials. Always follow proper safety procedures when working with communications cables and wear appropriate personal protective equipment. When installing LMR-400-DB cable, several key characteristics should be considered. Firstly, LMR-400-DB cable is a low-loss coaxial cable commonly used for radio frequency applications. Secondly, it has a characteristic impedance of 50 ohms, which is a standard impedance for RF systems. Thirdly, it is available in various lengths and with different connector types to suit different applications. Fourthly, it has a solid center conductor, which provides excellent signal conductivity. Fifthly, it has a braided outer conductor, which provides shielding against electromagnetic interference. Sixthly, it has a durable jacket that protects the cable from environmental damage. Seventhly, it has a wide operating temperature range, making it suitable for use in a variety of climates. Eighthly, it has a low attenuation, which means that it loses very little signal strength over long distances. Ninthly, it has a high velocity of propagation, which means that signals travel through the cable very quickly. Tenthly, it is relatively flexible, making it easy to install in tight spaces. Finally, it is widely available and competitively priced, making it a popular choice for many RF applications. When installing LMR-400-DB cable in a building, it's important to be aware of the potential for electromagnetic interference for EMI. EMI can disrupt the performance of electronic equipment and can even cause damage. To minimize EMI, the following steps should be taken. Firstly, use shielded connectors to prevent EMI from entering or exiting the cable. Secondly, ground the cable shield properly to provide a path for EMI to flow to ground. Thirdly, separate the LMR-400-DB cable from other cables that may be sources of EMI, such as power cables. Fourthly, use filters to block EMI from entering or exiting the equipment connected to the cable. Fifthly, use surge protectors to protect equipment from voltage spikes that can cause EMI. Sixthly, use a spectrum analyzer to measure the level of EMI in the area and identify any potential sources of interference. Seventhly, use ferrite beads to suppress EMI on the cable. Eighthly, use conduit to shield the cable from EMI. Ninthly, use shielded enclosures to protect equipment from EMI. Tenthly, use twisted pair cables to reduce EMI. Finally, consult with an EMI expert for assistance in identifying and mitigating EMI problems. In the specific case of running LMR-400-DB cable with 12 volts direct current and 15 dBm of RF power, it's important to consider the safety implications. Firstly, 12 volts DC is generally considered a low voltage and is not typically hazardous, but it's still important to take precautions to avoid electrical shock. Secondly, 15 dBm of RF power is a relatively low power level and is not typically harmful, but is still important to avoid prolonged exposure to the RF field. Thirdly, the cable should be properly insulated to prevent electrical shock and to protect the cable from environmental damage. Fourthly, the cable should be properly grounded to provide a path for electrical current in the event of a fault. Fifthly, the cable should be properly supported to prevent damage and to ensure its longevity. Sixthly, the cable should be protected from physical damage, such as pinching or crimping. Seventhly, the cable should be kept away from flammable materials to prevent a fire hazard. Eighthly, the cable should be inspected regularly for signs of damage or wear. Ninthly, the cable should be replaced if it is damaged or worn. Tenthly, a qualified electrician or communications technician should be consulted if there are any concerns about the safety of the installation. Finally, it's important to be aware of the applicable codes and standards for electrical and RF installations. When discussing the LMR-400-FR cable, it is essential to understand its fire-resistant properties. Firstly, LMR-400-FR cable is a fire-retardant version of LMR-400 cable, designed to meet specific fire safety standards. Secondly, it is typically used in plenum spaces, risers, and other areas where fire resistance is required. Thirdly, it is constructed with materials that are designed to resist the spread of fire. Fourthly, it is tested to meet specific fire safety standards such as UL 910 and NFPA 262. Fifthly, it is typically more expensive than standard LMR-400 cable. Sixthly, it is available in various lengths and with different connector types. Seventhly, it is compatible with standard LMR-400 connectors and accessories. Eighthly, it is easy to install using standard cable installation techniques. Ninthly, it is clearly marked to indicate its fire-resistant properties. Tenthly, it is an important component of a fire-safe communications system. Finally, it should always be used in accordance with applicable codes and standards. The NEC National Electrical Code plays a significant role in specifying acceptable wiring methods and materials for communications systems to ensure safety and prevent fire hazards. The code stipulates that cables installed in certain locations within buildings must have specific fire resistance ratings. This is primarily to limit the spread of flames and smoke in the event of a fire. In addition to adhering to the NEC, installers must also comply with local building codes, which may have additional or more stringent requirements. These local regulations often take into account specific regional factors or building characteristics. Building inspectors are responsible for enforcing these codes and ensuring that installations meet the required safety standards. They may conduct inspections at various stages of the installation process to verify compliance. Understanding the relationship between the NEC, local building codes, and building inspectors is crucial for ensuring a safe and code-compliant communications system installation. Firstly, always consult the latest edition of the NEC and any applicable local building codes. Secondly, obtain the necessary permits before starting any installation work. Thirdly, work with a qualified electrician or communications technician who is familiar with the code requirements. Fourthly, schedule inspections at the appropriate stages of the installation process. Fifthly, address any issues or concerns raised by the building inspector promptly. Sixthly, maintain accurate records of all installation work, including permits, inspections, and materials used. Seventhly, ensure that all cables and equipment are properly labeled and identified. Eighthly, provide adequate access for inspection and maintenance. Ninthly, educate building occupants about the fire safety features of the communications system. Tenthly, conduct regular inspections and maintenance to ensure that the system is operating properly. Finally, be prepared to make necessary repairs or upgrades to maintain compliance with the code requirements. In the context of the question, the exception within NEC 800.41 subsection B, which allows for short runs of non-fire rated cable in raceways, highlights a practical consideration. While the general rule mandates fire rated cables inside buildings, the exception recognizes that limited lengths of standard cable, when properly enclosed and protected, pose a minimal fire risk. This exception can save costs and simplify installations in certain situations. However, it is crucial to carefully evaluate the specific circumstances and ensure that all conditions of the exception are met. Factors to consider include the length of the cable run, the type of raceway used, the location of the cable within the building, and the overall fire safety design of the building. If there is any doubt, it is always best to err on the side of caution and use fire-rated cable. Finally, it's very important to note that the information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or communications technician to ensure that your installation meets all applicable codes and standards.